All right, let's jump straight in. We're looking at the paper, a practical guide for designing, developing, and deploying production-grade agentic AI workflows. And this is a huge headache for AI engineers right now.
It really is. It's about how you move from those cool, one-off prototypes into something that can actually run reliably in an enterprise system.
So what's the big paradigm shift they're talking about here?
Well, what's fascinating is that we're moving way beyond just feeding an LLM a single big prompt. Agentic AI workflows, as they define them, integrate multiple specialized LLM agents.
Okay, so like a team of AIs.
Exactly. Each one has its own tools, its own orchestration logic, and they can interact with external systems. It's all about executing these really complex, multi-step tasks pretty much autonomously. Think of it like a self-driving pipeline.
Right, and that gets to the core challenge, doesn't it? The paper makes it super clear that building a proof of concept is, trivial. We've all done it.
Oh yeah, a Jupyter notebook, a few hours, and you've got something cool.
But productionizing it is a whole different ballgame. You immediately hit these fundamental software engineering problems. Reliability, determinism, which is a nightmare with LLMs, and then all the governance and responsible AI requirements.
Exactly. And the solution they propose isn't just, write better prompts. It's a proper, structured engineering lifecycle. They've distilled it down into 9 core best practices.
And these are based on real-world implementation.
Right, absolutely. Actionable things like prioritizing a tool-first design or using pure functions for any deterministic infrastructure tasks. And, crucially, implementing single responsibility agents. One agent, one job.
And what about building trust? This is the key insight for me. How do you mitigate things like bias and hallucinations?
This is their most powerful finding, I think. They deploy a multi-model LLM consortium. So you have several models generate drafts in parallel.
Different models like GPT, Gemini, Claude.
Right. And then a dedicated reasoning agent comes in. Its only job is to synthesize those different outputs, resolve the conflicts, and actively remove any speculative claims. It strictly grounds the final output in the source material. That's your blueprint for a trustworthy system.
And they actually built this, right? This isn't just theory.
Not at all. These principles are demonstrated in a fully implemented, fully containerized workflow that autonomously generates a news podcast script and even publishes it to GitHub. It's a real end-to-end system.
Oh, okay, so let's dig into that. Why is moving from that simple script prototype to a full production deployment so incredibly complex? For anyone who hasn't tried to scale agents yet, what are the big pitfalls?
You can really break it down into 3 areas: design, implementation, and operations. Let's start with design.
Okay.
The first job is just figuring out how to decompose the workflow. How do you break a huge task like create a podcast into specialized steps without creating, too much overhead?
And you also have to decide how to connect to the outside world.
Right. Do I use an explicit tool call, or do I use something more abstract like the Model Context Protocol or MCP? And all the while, you're trying to design for deterministic orchestration and avoid these implicit behaviors that inevitably lead to LLM drift.
Okay, hang on a second. LLM drift. Can we unpack that? Because in a traditional pipeline, that means one thing, but here, what does implicit behavior even look like in an agentic workflow?
That's a great question. In these systems, implicit behavior is when you rely on the LLM's memory or conversational history to carry context between steps instead of passing structured data explicitly.
So like hoping agent B remembers the URL that agent A just found.
Precisely. And when the underlying model from the vendor gets a silent update or you tweak a prompt slightly, that implicit context can just disappear. It becomes unreliable, and suddenly your whole workflow breaks for no obvious reason. Deterministic design demands explicit state passing at every single step.
Got it. So even if you nail the design and the explicit state, implementation still has its own set of traps.
Oh, absolutely. Implementation is where you manage the messy reality of multi-agent communication. Who talks to whom? How do you handle failures? How do you keep the state consistent? You're managing tool schemas, keeping prompts modular so you can change them without a full redeploy.
And you're trying to wrangle all these different model families, OpenAI, Gemini, Anthropic. They don't all behave the same way.
They don't. They have subtle differences in how they handle tool calls or system prompts. And on top of all of that, you have to actually enforce your responsible AI principles across this entire complex pipeline.
And then comes the brutal part, operational scaling. That's usually where the clever design falls apart under real-world load.
Yeah, the operational challenges are probably the toughest for long-term production. You need to manage concurrency running hundreds of these workflows at once. You need intelligent retries for when things inevitably fail.
And cost. I imagine the token costs can get out of control very quickly.
Hugely expensive, especially with GPT-4 class models. So you have to optimize for cost. You have to secure access to all your tools and API keys. And maybe the hardest part, ensuring that every run is reproducible, even when the foundational models are getting updated by the vendor without you knowing.
Wow. That last point alone really drives home the need for rigor.
It absolutely requires things like containerization and strict versioning.
That detailed breakdown is the perfect setup for the use case they built, the automated podcast generation workflow. Can you walk us through that architecture? It seems like a fantastic example of specialization in action.
It is. It's a highly specialized sequential pipeline.
Yeah.
It all starts with a web search agent. Its job is to fetch the latest news from RSS feeds or search endpoints.
Okay, so it gets a big raw list of stuff.
The raw list, exactly, which then goes to the topic filtering agent. Its only job is to cut through that noise based on what the user actually wants and just return a clean list of relevant URLs.
Right, so you're specializing from the very first step. You're trying to reduce the cognitive load on those bigger, more expensive agents down the line.
That's the whole philosophy.
Yeah.
Then the web scrape agent is critical. It doesn't just grab raw HTML. It extracts the page content and converts it into clean, structured markdown.
So it's a normalization step.
It's a massive win for determinism. It guarantees that every downstream agent gets a consistent, predictable input format, no matter how messy the source website was.
Okay, so now we get to the core generation part. And this is where they bake in that reliability through diversity.
Yes. The system calls a whole consortium of podcast script generation agents. It spins up instances on OpenAI, Gemini, Anthropic, all at the same time. The goal isn't one perfect script. It's to get a bunch of diverse drafts.
And they found the models have different styles.
They did. Llama might give you a really concise summary. OpenAI generates a more detailed narrative. Gemini is great for stylistic flow.
That's fascinating. But that diversity also creates inconsistency, which must be why the next component, the reasoning agent, is so important. Is it basically acting as an internal auditor?
That's the perfect analogy. It is the critical consolidation and trust layer. Its prompt explicitly tells it to compare all the drafts, resolve any inconsistencies, and remove speculative claims.
And here's the key. It has to ground everything back to that original markdown content, right?
Exactly. It's an enforced reality check. Every single claim in the final script must be traceable back to the extracted source material. This ensures consensus and factual alignment before anything else happens.
Brilliant. So once that consolidated script is ready,
the audio-video script generation agents take over. They transform that final narrative into structured prompts, optimized for models like text-to-speech, or in this case, a text-to-video model like VO3.
And the whole thing ends with the PR agent.
Right. It bundles up all the final assets, the script, audio instructions, the video spec, and it automatically publishes them to GitHub via a pull request. The whole deployment cycle is automated.
The beauty of this is that it gave them a live test bed to really validate their 9 best practices. You can see exactly why the initial designs didn't work and why the fixes did.
Precisely.
That makes this the perfect time to transition into those 9 actionable rules. Let's start with how agents should interact with the outside world.
So the first rule is tool calls over MCP. Now, the Model Context Protocol is great in theory. It's a standard way for agents to talk to external services. But the authors found its abstraction layers can actually increase non-determinism.
How so? It seems like a standard API would be a good thing.
It can be, but it can also complicate the agent's reasoning process and lead to really ambiguous tool selection behavior from the LM.
Right. I remember they had a specific example of this with their GitHub integration. But if you prioritize explicit tool calls, aren't you just trading the LLM's unpredictability for more operational complexity on your end?
That is the classic engineering trade-off. And you're right, there is more configuration overhead. But the stability gain they found far outweighed that cost. Their first GitHub MCP integration caused what they called flickering, non-reproducible failures.
Because the agent just couldn't figure out the MCP structure.
Exactly. It struggled to parse the metadata and parameters correctly. As soon as they replaced it with a direct, explicit function invocation, a simple tool call, the ambiguity vanished. The system became rock-solid stable.
So building on that, best practice number 2 is direct function calls over tool calls, pure functions. This feels like the ultimate expression of that idea. For some actions, just take the LLM out of the loop entirely.
Exactly. If a task is deterministic by nature, writing to a database, posting to an API, creating a file commit, making that final GitHub PR, you don't need LM reasoning at all.
The agent doesn't need to reason about how to post a JSON file.
It doesn't. And if it's not reasoning, it shouldn't be involved. Using pure functions that are executed directly by the orchestration layer saves tokens. It completely removes any chance of LLM misinterpretation. And it's just faster, cheaper, and totally deterministic.
Plus, fewer points of failure. The LLM becomes an expensive, non-deterministic middleman for a simple task.
Precisely. And the paper shows them doing just that. They literally remove the PR agent entirely in the final version and replace it with a direct function call from the workflow runtime. A huge simplification.
Okay, let's talk about structure. Best practice 3 is about modularity. Avoid overloading agents. One agent, one tool. This sounds like they're fighting the temptation to create a super agent that does everything.
They absolutely are. When you attach multiple tools to a single agent, you increase its cognitive overhead exponentially. The LLM has to waste reasoning cycles just figuring out which tool to use, let alone how to use it.
And that leads to errors.
All the time. Incorrect parameters, calling tools in the wrong order, or just missing a call entirely. The modular approach, one agent, one tool, makes the agent's behavior predictable.
What was the specific failure they ran into with this?
Their first version had a single content extraction and publishing agent. It was responsible for both scraping the content and then publishing the final result. So it had two tools, scrape markdown and publish content.
And I'm guessing it got confused.
Constantly. It would call them in the wrong order, or because the goals were kind of in conflict, it would only call one and then stop. Splitting that into two separate specialized agents made each step deterministic.
And that flows right into best practice 4, the single responsibility agent. No mixing of planning, execution, and validation in one agent.
This is so critical for avoiding what they call hallucinated side effects. The best example is their video generation step. They realized an agent shouldn't try to plan and execute.
So they split it.
They split it. The VO.json builder agent only does the planning. Its job is to turn the final script into the valid JSON that the VO3 API needs. Then, a separate non-agent function handles the execution, actually calling the API, handling the file output.
So the LLM is only doing the creative structural work, not the operational stuff?
Exactly. This stops the LLM from hallucinating file paths or API status messages about things it has no business knowing. You keep the LLM focused on reasoning, and you segregate the operational tasks.
Okay, moving into governance and maintenance. Best practice 5, store prompts externally.
This one is huge.
Well,
Embedding prompts directly in your code is a maintenance nightmare. It ties the AI's entire behavior to your engineering deployment cycle.
so if a policy person wants to tweak a safety constraint, they have to wait for a full code release?
Right. But if you store prompts externally in a config file, a database, even just another GitHub repo, you decouple the agent's behavior from the code. This means non-technical stakeholders, like your policy or legal teams, can refine those guardrails without ever needing to involve an engineer. It's faster, it's safer, and it makes A/B testing prompts so much easier.
Which brings us to what is arguably the most important principle for trust. Best practice 6. Responsible AI via a multimodal consortium. Let's spend a moment on the actual mechanism of that reasoning agent. How do you make sure it doesn't just synthesize the most common hallucination?
This is where the architecture is so clever. They use diversity as a weapon against hallucinations.
Yeah.
By having multiple different LLMs, Gemini, GPT, Llama generate drafts in parallel, you create a kind of mandatory peer review.
And the reasoning agent isn't just told to find an average.
Not at all. It's given a very structured set of instructions. Its prompt tells it to actively search for claims that are in one draft but are contradicted or absent in the others, and to discard them unless they can be strictly verified against that original markdown input.
So it's not looking for the highest common denominator. It's actively looking for the weakest, most speculative claim and removing it. It's a system designed for skeptical consolidation.
That's the perfect way to put it. The consolidation step is reductive and restrictive, not generative. By forcing consensus and requiring that explicit grounding, they create a unified, trustworthy output, and they seriously mitigate the risk you get from relying on a single model to self-correct.
Moving to the architecture, best practice 7. Separation of the agentic workflow and the MCP server. Why is that decoupling so important for production?
You want to treat your agentic workflow, the thing with all the complex logic and tool orchestration, as a standard high-performance back-end REST API. The MCP server then just becomes a lightweight adapter, a thin translation layer that forwards MCP calls to your robust API.
And that lets you scale them independently.
Independently, yeah. All your complex business logic lives in the API where you can properly secure it, monitor it, and scale it, while the MCP server stays simple, stable, and compliant.
Best practice 8 is a classic for any modern system. Containerized deployment.
For production, there's just no way around it. You have to use Docker and Kubernetes. With these multimodal workflows, containerization is essential because it guarantees a consistent runtime environment. When you're juggling SDKs from 5 different vendors and specific Python versions, consistency is everything.
And you get all the operational benefits.
All of them. Portability, auto-scaling, robust security through RBAC, and seamless integration with the centralized logging and observability tools that any enterprise system needs.
And finally, best practice 9. Keep it simple, stupid.
Kiss. It's almost comforting that after all this new complexity, we end up back at the basics of good software design.
It is, but it's especially critical here because complexity just compounds an LLM's ambiguity. The authors found that agentic workflows thrive on simplicity, avoid deep inheritance, avoid elaborate design patterns.
Why is that? Because flat, readable, function-driven designs reduce the ambiguity for the LLM. It improves the predictability of tool calls, and it also integrates much more naturally with AI coding assistants like Copilot, which speeds up your iteration time. Complexity just gives the LLM more opportunities to get confused.
Let's get to the results then. After all that engineering overhead, did the system they built actually work? Was it reliable?
It absolutely was. The evaluation confirmed it. First, the script generation step showed exactly the diversity they hoped for. Llama gave concise summaries, OpenAI gave a detailed narrative, and Gemini focused on stylistic flow. That diversity was valuable, but it also proved why the consolidation step was so necessary.
And what's the concrete proof that the reasoning agent actually succeeded in mitigating risk?
The proof was in the content stability. By strictly following its instructions, prioritizing details mentioned in multiple drafts, and throwing out speculative claims, the reasoning agent produced a final script that was both coherent and factually stable. It proved their hallucination mitigation strategy works in the real world.
They successfully traded that diversity for stability at the most crucial point.
Exactly.
And what about the multimodal outputs? Did it manage to generate clean, executable instructions for the video?
Flawlessly. The structured approach paid off. The video script agent reliably turned the narrative into scene JOS descriptions, and then the VO3 JSON builder agent consistently produced syntactically valid and executable JSON. It proves that a specialized multi-agent planning process can translate directly into executable artifacts without hallucinating unusable code.
And for the engineers listening, the final proof of production readiness was the external validation, right?
Right. The entire system, built with the OpenAI agent's SDK and fully containerized, was successfully integrated with LM Studio, which acted as an external MCP client. It proved that other systems could reliably call this complex workflow, confirming its robust design. It is genuinely production ready.
So let's tie this all together. For the engineers out there wrestling with their own prototypes, the key takeaway from this deep dive seems to be that production-grade agentic AI is no longer just a prompt engineering problem. It's a full-blown software engineering challenge focused on determinism, specialization, and robust orchestration.
Precisely. And connecting this to the bigger picture, the authors suggest that the next frontier isn't just about robust execution. It's about creating systems that are adaptive and truly trustworthy. And that raises a really important question for you, the engineers and researchers listening. As these multi-agent pipelines get more complex, just executing the task isn't enough. What's the next engineering challenge? It has to be building adaptive evaluation pipelines, integrating workflow self-monitoring, and weaving safety and guardrail mechanisms directly into the orchestration layer itself, not just relying on the models. To guarantee trustworthiness in a world that is constantly changing, that's the challenge that lies ahead.